I am going to talk to you about general purpose telerobotics. The question is, where's my teleportation robot? I have 5 aggressive goals that I may fail to achieve during this talk. First, I want to convince you that telerobotics is just as worth paying attention to as aging or climate change. We've had some really heavy topics during this workshop, and I feel like many people know about them. Very few people know about telerobotics or take it seriously. 2, I want to convince you that telerobotics isn't just AI's lame cousin. 3, I want to show you that telerobotics isn't a solved problem, but actually requires a dedicated research program. 4, I want to argue that without intervention, general purpose telerobotics won't happen, and that it is possible to intervene so that it does. And 5, I want to present some potential interventions, both technically and incentive-wise, to enable general purpose telerobotics. Telerobotics has a PR problem. Many people have never heard of it. I say telerobotics, they say what's it. For people who have heard of it, generally one of these 2 sort of ideas come to their mind. It's either this big chonking thing from the 1950s where you have a guy manipulating this mechanically connected robot arm to do a thing on the other side of a lead wall, or you have an iPad on a Segway. And that's what I think of telerobotics as. And even in the field of robotics itself, telerobotics is kind of this this maligned topic where it's kind of like that seedy bar where you'll go to get a drink and maybe pick up a date, but you never really want to admit to anybody that you went there. And so people will sort of go there to publish a paper or 2 and then hide their face in shame and go do something else. What I want to argue is that telerobotics could be so much more than this. There's a quote I love from Ada Palmer. All technology is a prosthetic god, a set of tools we weak humans strap on to give ourselves the powers we crave. Computers for omniscience, trackers for omnipresence, medicine for immortality, armor for invulnerability, and guns for heaven's wrathful thunderbolts. And so general purpose telerobotics can help us take on some of these aspects of godhood. So general purpose telerobotics should be able to give us Hermes' immense speed and ability to travel great distances very quickly. It can give us Hercules' strength by allowing us to basically embody a construction robot that could pick up an I-beam and put it somewhere. And it could allow us to have Athena's dexterity and ability to hold something still for a very long time and do extremely precise movements. And this is sort of just a subset of the things that a working general purpose telerobotics technology could do. And I realize I'm using the term general purpose telerobotics to distinguish it from sort of the more general idea of operating a robot remotely. And the way that I think of general purpose telerobotics, and this is how you know that it works, is that it allows a person to use a robot as an extension of their own body at distance. And the clutch, there's 2 key things there. One is this idea of it being an extension of your own body. And that's really important because there are many things that you're doing it, but it feels really clunky. And it's sort of the difference between before the iPhone and after the iPhone. And it's even though the iPhone isn't it doesn't have 0 latency, but it just feels seamless. And so that feel is really clutch. And then the second part is the at a distance piece. So something that comes up, another sort of elephant in the room that I want to call out is that often telerobotics is dismissed because people ask why not just make an automated robot? It's people are doing a lot of good work on robotics. Why do you even want a person operating the thing? And so there are some transient arguments about the capability of robotics versus telerobotics. I want to ignore those transient arguments and instead I see in the long term, telerobotics is about people, not the tasks. And I see telerobotics as a computer for the hands in the same way that computers can be a bicycle for the mind. And again, that they are a tool that allows people to do people things like better, stronger, faster, and from farther away. And so that's the framing of it vis-a-vis automated robotics. Another question that comes up very frequently isn't telerobotics a solved problem? In that, like, you see things like this, right? Like, you see Jeff Bezos operating these things, and like it looks like they have a fully working system. Like, why? Like, what's the problem here? And you see many of these examples, and so the sort of the rest of the presentation is going to be me trying to convince you that Telerobotics is in fact not a solved problem. And not only is it not a solved problem, but that it's not just sort of a matter of like revving a few more times on these systems that you see here. I'm going to blast through a number of Telerobotics has been around since they started using telerobots to operate to manipulate nuclear material on the other side of a lead wall in the 1950s. And I'm just going to blast through what I would call sort of like the frontier of different lineages of telerobotics, just to give you a sense of like A, where things stand, and B, to sort of put things that you may have seen in context. So one of the lineages is around nuclear material handling. Another is around surgical telerobotics. And so nuclear material handling is very much optimized for very short distances and a very small subset of tasks, but just in such a way that they need to be, that like it can't quite be automated, and you can't have a person just doing it because of radiation. Surgical telerobotics, like you have the Da Vinci robot is the most well known, is designed to allow a surgeon to do these very, very fine-tuned, precise movements very, very slowly, and again is well suited to a small subset of tasks. NASA and the European Space Agency have also been working on telerobotics for decades. The issue is that, like a lot of NASA and ESA research, it's never meant to go anywhere, and so the researchers are just kind of doing it as like a holding pattern. So it really, there's nothing forcing it to become a really powerful technology. The military uses remotely operated robots to defuse improvised explosive devices, but has not really pushed the technology forward. There's telepresence robots. These are your iPads on a stick. They're really concerned sort of with latency, but there's really no evolutionary pathway from there to this interaction piece that is really clutch. There's sort of another lineage around avatars, which are really focused on making you feel like you're in a place, but not so much on the quality of the interaction with that place. It's these ones, they tend to be optimized for demos. And then there are a whole bunch of academic lineages, which are sort of like people working on small subcomponents. So you have people working on dexterous hands. You have people working on haptics. That's your sort of touch feedback. You have people working on compliant arms. And so these are robot arms where if they bump into something, like if I do this, my hand kind of deforms and smushes into my face, as opposed to most robot arms where if I tell the robot arm to like go over there, the robot arm will go over there no matter what is between that robot arm and over there, including like people's fleshy bodies. And compliant arms are arms that can deal with that. And then sort of various interfaces. That is like how does the person, like there's the naive thing where you just sort of like project a video of what the robot's doing, and like you map movement one-to-one between what the person's doing and what the robot's doing. But there's a number of issues with doing that I'll get to, and so there has been some work on that. So there's been a lot of pieces of the puzzle done, and then there's always the question of like, why should we care about this now? I'm going to blast through a bunch of reasons. One, virtual reality has driven a lot of advancement both in the hardware ecosystem, right? So people have done work on virtual reality headsets, which can make you feel like you're in a 3D environment. In addition, but also haptic sensors and other things that help you feel like you're in an environment. So ideally, you'd be able to sort of port some of that technology from feeling like you're in a virtual environment to feeling like you're in a real environment somewhere else. In addition, there's been a lot of interaction design in VR of like dealing with constraints of like, okay, you're in VR, like how do you move? Like they came up with these really clever ways of like teleporting and seeing what you're actually doing in that space. Deep learning has sort of hints at potential useful things for telerobotics in two places. One is in robot control. I'm sure most of you have seen OpenAI's Dactyl, where they had the robot hand that learned to manipulate a Rubik's Cube. And one could imagine this being used for like motion primitives, where instead of needing to like me as the human operator needing to like actually say like, okay, I'm going to move my fingers like this. It's much more like a video game where it's like point and click and be like, okay, I want to interact with that cup. In addition, sort of coupled, you have what's called scene understanding. So really sort of saying like, okay, like there is a cup there. This is the 3D shape of a cup. This is what a cup is. And deep learning has really helped with that. Physics-based simulations have been pushed forward just through the video games industry. You look at SIGGRAPH, just like keeps doing more and more crazy things every year. And batteries and motors have actually been driven forward by the drone industry because they really care about having like really, really power dense motors. And that can really then potentially help with robotic arms. The real bottleneck with the like meta bottleneck of telerobotics is that it is a massive systems problem. It is a extremely high dimensional design space, and so there's a set of there's incentive problems on getting people to work on the system. There is a set of 5 like very, very tightly coupled subsystems that you can't optimize on their own. And then there's the need for a serious context of use. And I know I talk about serious contexts of use all the time, but this is another, I guess I'm very interested in problems where I think that they're important. So normally I would want to talk about the sort of like, normally talking about the technical pieces is actually the least important part of these problems, but I want to talk about the technical pieces first in order to give you context on the other 2 areas that I'm going to talk about. So within general purpose telerobotics, there's sort of like 5 real subsystems. So there's the interface. There's like that's the thing that you as the operator are interacting with. It's what you're seeing. It's what you're feeling, and that within that there's like how do you how does it know what your hands are doing? How do you see what's going on? How do you specify to the robot what do you want it to do? Then there's latency, which is just like literally what is the round trip time between you and the robot and back to you? Because anytime there's latency, and there will be latency, you're issuing commands to a future robot and you are getting information from a past robot. And that presents a whole suite of problems. There's the question of actuators. That's the robot arm, the robot's hand. How do you make sure that you're not just willy-nilly destroying things when the fact that you have latency means that you issue a not the perfect command to the robot. There's the question of control systems, right? So this is how much of how much autonomy is in the robot? Is it something where it literally tries to do exactly what you're doing with your body? Do you issue command low-level commands like grab that cup? And then finally, there's the sensors of how does it know what the environment looks like? Is it scanning with a 3D scanner? Do you have binocular cameras? Do you have weird cameras around the robot? Going back to the dactyl example from OpenAI, it wasn't just a binocular camera looking at a hand. They had this whole rig. And so what do you need to do there? And the trick is, with each of these design choices that you make in the architecture for any one of these affect all of the others. So for example, if you figure out if you could somehow magically make the latency zero latency, right? Somehow defy the speed of light and be able to just have zero latency between yourself and the robot. The interface that you would want to use would be this very you just want the raw video stream basically, and then you wouldn't care too much about your actuators because you wouldn't worry too much about bumping into things. And you wouldn't really need a super complicated control system, and you could probably just get away with a binocular camera. However, latency is not going to be zero, and depending on how big it is, you need to compensate it for it with perhaps a interface that does the thing that lets you interact with the robot more like a video game, which then puts demands on the control system and puts demands on the sensors and puts demands on the actuators. And similarly, if you had a really good compliant arm, you would not need to worry as much about the control system. However, to get a compliant arm working, it's actually the control systems that we have right now are very much built for arms that are rigid and position controlled as opposed to force controlled, which you need to do a compliant arm. I'm not going to go into it, but I'm mostly throwing all of this out at you to just give you a sense of how interconnected all of it is, and how to actually build the system, you need to be doing work on all of these pieces at once. Okay, so those are the technical areas, and this is just to sort of illustrate that the technical architecture is this ridiculously high dimensional design space, and it's not clear even which place is the local optimum to go for. And so through the view of the optimization landscape, I think of serious context of use as they're incredibly important for telerobotics because similar to a machine learning system, most contexts of use will push a telerobotic system to over-specialize. So in most cases, you don't actually need a general purpose telerobotic system. And so there's sort of these conditions on the serious context of use that sort of act like a forcing function to make sure that it is general enough. Some include space. So you could imagine someone you want to mine on an asteroid. It would be a lot more convenient if a person could stay inside a nice either habitat on Mars or a spaceship and be operating something remotely. Oil and gas and mining involve a lot of, it is very, very dangerous for people to be there, and many of them would like to sort of eliminate that. Elder care is another one where, I guess, satisfies the condition that there are many different tasks that one would need to do, and automating it would be incredibly hard. And one that I really like is the idea of lab work. You could imagine having a 24-hour utilized lab where you have the Asia shift, and then you have the Europe shift, and then you have the North America shift, and they're all working in the same lab on the same equipment, basically telecommuting via the robot. Each of these has there are problems with each of these that need to be overcome. So, for example, space, it's not a serious context of use yet because nobody is really doing the things in space that one would want to use a robot for yet. So there's a little bit of a chicken and egg there. Oil and gas and mining. Unfortunately, general purpose telerobotics would basically just be a cost saver there, and it's very hard to get people on board with a long-term, uncertain, expensive research program to simply reduce costs in the future. Elder care is just the bar, the minimum viable thing. The bar is extremely high because you're not only in people's houses, but you're interacting with their loved ones. And lab work has this problem where no researcher will want to decrease their output to sort of mess around with an experimental system. All of these could be overcome. I just want to point out that figuring out the right context of use is extremely important. And finally, there's sort of the incentives to do the kind of work that needs to be done to make general purpose telerobotics a thing. And so there's the academic incentives where academics mostly just the incentives are to do a novel thing, beat some metric that you've made up, and then publish a paper about that, and then move on. I don't know how many researchers I've contacted and been like, hey, I saw this paper, it was super cool, what's the status of this thing? And they're like, oh, I don't work on that anymore. The startups incentives, the fact of the matter is that for any given application right now as a startup, it would make more sense to make an automated robot or a specialized telerobot. And there are companies doing that. And so it has to do with this local optimization thing. And then at big companies, it's this thing where there's not enough near-term use, and the long-term pain that one would hope to solve is not great enough. So a number of big companies have spun up telerobotics programs, and then they have shut them back down. And so that is why we sort of need a new set of incentives to push through that. I'm going to blast through a couple of so instead of just being it's this huge design space, I'm just going to throw out some potential regimes in design space that might work. One is the sort of, as I've mentioned before, something that looks a little bit like a video game. So it's this sort of dynamically supervisory system where sometimes when you really need to, you go in and you do I'm doing this with my fingers, but most of the time you're it's point and click. Another is if you could make the latency massively lower, literally build a global network just for telerobotics that cut out the internet and reduce the latency to a point where it's sort of within human reaction loop. You would be able to do something many of the systems that we have now would then become incredibly useful. I also just really like this picture of Jeff Bezos. And another sort of crazy one is that what you do is you, like, as the operator, you're interacting with a simulated world that is being informed by data from the robot. So at no point are you like looking through the robot's eyes. Like, you're interacting with this world, and the robot's interacting with the real world, and you just have the ability. You're just like syncing between them to make that happen. And so one, again, like, we're not supposed to suggest too many things. One of the, I think, the potential paths forward is that something that sort of wouldn't happen in academia, wouldn't happen in startups, wouldn't happen in a big company, is building a telerobotic PR2. And just like a brief history, the PR2 is this experimental, like a research robot platform that was built by this organization called Willow Garage, that was, it cost about, I think it cost about $100,000 per robot, and they gave them to a bunch of research universities. And like most of the good robotics research that was done in the like early to mid 2010s was done on these robots because they existed. They never would have been built by a startup or a big company or in academia. And so the question is, like, could you do something similar for telerobotics in a modular way that would let researchers sort of like explore design space? My biased opinion is that this that telerobotics falls squarely into the realm of too researchy for a startup and too engineering heavy for an academic lab. DARPA's not going to do it because, like, explicitly talking to DARPA directors or DARPA PMs about telerobotics, they're like, we just care about autonomy, and telerobotics just sort of needs to hang out in the valley of death for a while. And just to like very concretely give you, this is a made up scenario. This is not me saying like this is the thing, but like this is what a program could look like. Is you basically have a workshop where you pull together like a huge number of disciplines that aren't talking. You get like video game designers, and you get roboticists, and you get people who might come along with serious contexts of use, and you get all like the different branches of like get the different lineages together, and you figure out like, okay, like what should be what should be the goal. And like, say for example that they realize that like, oh, the goal could be this telerobotic PR2, then you have a bunch of groups who do sort of like the first steps on each of the components. Like you sort of like have them working on like those 5 different areas, and then finally you figure out who you like working with, what is promising, and you come together into something that's like an FRO to actually like build the robot, all the while sort of keeping everybody from oil and gas companies to people who are interested in space in the loop to try to like have as much of a forcing function and on a serious context of from a serious context of use as possible. And then zooming out, what would it look like to have general purpose telerobotics shift from impossible to inevitable? I sort of think of it as like, what does like the DARPA Grand Challenge moment look like for general purpose telerobotics? So you start with that ARPA style program that I was just mentioning. Eventually, like you spin that out into an organization that is like its job is to create these research robots. That might be a nonprofit, it might be a like low profit, for profit. And then you like, once enough people have enough experience sort of like playing around with these things, then you could sort of do something like the DARPA Robotics Challenge, or like the DARPA Grand Challenge or the DARPA Robotics Challenge, where you say like, okay, use these things to actually do something that you couldn't do before. And then like what then happens is what happened with autonomous vehicles, where then like the top teams sort of like shatter, and all the people from those teams either go to like big companies like Google, or they go and they start their own startups. And like now, if you look at, again at the analogy to autonomous cars, like we don't have autonomous cars yet, but there's just like feeling that it's just a matter of time. And like, that's really what we're going for here.